All right. So far we have covered all the concepts which are related to, chapter number 1, which is the introduction. So today we will do some problems, some questions. Let me show you the questions first. So guys, wherever on the website where you see chapter notes, after the chapter is finished, you will see something like this. So let's say chapter 1 we are talking about. So you will see this. So these were the notes from the chapter, for the chapter. And then you will see these past year questions. So you should practice. Once the concept is done, you should practice from here. Okay. And keep practicing from your Devore book as well. All right. So, okay. So let's do these problems. Let's take this problem. All right. So this is lecture number 6, I think. Yeah. I think it's 5th. Okay. All right. So let's read the question and let's see what we have to do here. Okay. All right. You keep your notebooks and pens ready because we'll do it together. All right. Let me read the question then. The heights of 5 players in a football team have a mean of 76 inch, median of 78 inches, and a range of 11 inches. So it's usually a good practice to write whatever is given to us. So first of all, there are 5 players, right? 5 players. Mean value is 76 inches and median value is 78 inches and range is equals to 11 inches. Okay, that is given to you. Now, if they ask us the following question, first, if the tallest of these players is replaced by a substitute who is 2 inches taller. So, there are 5 players, so they have different heights. Whosoever is the tallest players among them, that person is replaced by a substitute. Let's say that player had some injury, the tallest player. So that person is replaced by another player who is 2 inches taller than that person. So now the question is, would these 3 measures change? And if yes, how? So the question is, would the mean, median, and range change in this case? And how will that change? Okay. So basically, you had 5 players. And let's say if we, write them in the ascending order, first, second, third, fourth, and fifth. So this is the shortest person. And this is the tallest person. Okay. This person is replaced by someone whose height is, let's say here the height was h. So this person's height is going to be h plus 2. Okay, that is what is going to happen. In that case, you have to tell me what is going to be the new mean, what is going to be the new median, and what is going to be the new range. Question clear here?
Yes.
Right. So first of all, let's see what happens to the range. What is range? Yeah, so very nice. So range is basically whatever is your largest value minus whatever is your smallest value. So initially, the largest value minus the smallest value was 11. But now, if you replace this tallest person with someone who's 2 inches greater, what will be the position of that person? Will that position be 5th only or 4th or 3rd or 2nd or 1st? What will be the position if we put them in the ascending order? So basically the question is, जो भी हमारा इंसान है जिसकी height h+2 है, will that person's position be 5th only, right? Will that person be the tallest or not? That is the question.
He'll be the tallest.
Yes,
He'll be the tallest only. So basically क्या है कि जो height है, जो भी इसकी height थी, उससे 2 height add हो गई है, तो position 5th ही रहेगी. तो हमारी range क्या होगी? जो भी टॉलेस्ट इंसान है माइनस जो भी शॉर्टेस्ट है. पहले टॉलेस्ट माइनस शॉर्टेस्ट 11 था, अब इसकी हाइट 2 ऐड हो गई है, तो टॉलेस्ट माइनस शॉर्टेस्ट कितना हो जाएगा? 13, राइट? Is that clear? New range will be 13 inches.
Ma'am.
Okay. All right. Now, moving on. What will happen to the median? So, median is basically the middle value, right? Initially, what was the middle value? The third person. Now, if you increase the height is h plus 2. So, what will be the median now? Will the median change or will it remain the same?
It will be the same.
It will be the same because, the ascending order in which you have put, it will remain the same. So median in this case will again be the third person. So median is exactly the same. Median will be 78, right? All right. Now what about mean? How do you find mean in the new case? So what is mean? Mean is nothing but sum of all the values, sum of all heights, right? Divided by 5 people, right? Earlier, what was the sum of all 5 people? So because earlier mean was 76, right? And if I have to find the sum of all heights, so that will be this, right? Sum of all heights. What is this? What is 76 times 5? 0, 3, 38, right? 380. Height of the first position, height of the second position, height of the third position person, height of the fourth position person, height of the fifth position person, right? That will be the sum of heights. Now what has happened? There is one person, which was the fifth person. You have replaced him with someone who has a height of 2 units extra. So whatever is this sum, what will be the new sum?
Oh, 382.
382. 2 units extra will be there in the total sum of heights. So new mean is basically 382 divided by 5, right? Because that is the new sum of all the heights. So what is this going to be? Again, 7 and third 4, right? 76.4. Is that all right?
Yes, ma'am.
So इस तरीके से you will have to figure out the mean, median and mode. So range has changed, median has remained the same, and mean has also changed. Is that fine? Can we do this? Fine?
Yes.
All right.
Yes.
Okay, good. Chalo. Now move on and let's do the next problem, the second part. What is the second part saying? So now the second part is saying the following. That if the tallest player is replaced by a substitute who is 4 inches shorter. So now, the tallest player is replaced by someone who is 4 inches shorter. Which of the new value, the mean, median, and range, could you determine? What would their new value be? So basically, now what has happened? Earlier, this was first person, second person, third person, fourth person, fifth person in terms of height. Now what they have done is, they have replaced this person with someone whose height is h5 minus 4, right? Now you have to tell which of these 3 things, mean, median, and range, could you determine? Which of these values will you be able to find? And if you are able to find whatever value you say, what will be the new value? That is the question. Question clear? Hai?
I think we can find only the mean.
Okay, good. Mean can be found. चलो, mean कैसे निकालेंगे?
First we'll find the sum of all heights, then subtract 4 from it.
So sum of all the heights initially was 380. Now you have one person who has a height lesser than 4 inches. So you will remove this from here, right? And then how many people are there? 5. So the new mean will be this. Is that all right? So this is 376 divided by 5. So what does it give you? 7 and 75.2. Right?
Yes, ma'am.
This is fine. Mean
Yes.
कैसे निकालना है? ठीक है? Because you have replaced him with a person who is 4 inches shorter. So जो total height है उसमें से 4 inches कम हो जाएंगे. तो 380 में से 4 inches कम हो गए. And then we divided it by 5. So that is the mean. Okay. Now what about median? Can I find the median? If yes, what is the value? If not, why can't I find median?
Because we do not know the position of the substitute now.
Very nice. So basically, you know, it could very well happen कि जब आपने इस इंसान को रिप्लेस किया एक ऐसे इंसान के साथ जिसकी हाइट 4 इंचेस कम थी, हो सकता है अब जो चेंज आया हो उससे उसकी पोजीशन 4th हो गई हो सकता है उसकी पोजीशन 3rd हो गई हो सकता है उसकी पोजीशन 2nd भी तो हो सकती है, राइट? हो सकता है उसकी पोजीशन 1st हो गई हो. Is that right? So we don't really know if that person is in 3rd position now, 4th position, or this person still has this position intact. So because I don't know the position now, so I don't know how the numbers are there in terms of the ascending order, right? Yes.
Yes.
That is why I will not be able to find the median. Okay. Now, what about range? Range is the largest value minus smallest value, right? So now, can I find the range here?
No, ma'am.
Why? Can I not find it?
Because we don't know if he is the tallest person or not.
Exactly. So right now, I am not sure if this person is the tallest person or not. What if when we replaced him, this person position became this, right? Like 4th position. So this person would be the tallest then. So then I don't know what was the height of the 4th person, the 4th position person, or the final top person, right? So I don't know what is the largest value anymore. Okay. So that is why I will not be able to find range and median. So we won't be able to find the range and median. Is that clear? ठीक है?
Yes.
Perfect. So कर लेंगे if we have some problem like this in the exam.
Yes.
Perfect. All right. Let's do one more. Okay, so this is one question that we have. All right. So this question is the following. What is this question saying? That the marks distribution in percentage of students of a class was found to be symmetric. What does that mean? So let's say, you know, if you plot the graph of how many marks people got and you plot the histogram, it is turning out to be symmetric. That means, you know, you have something like this, that let's say the marks was from anywhere. So it is something like this. Okay, it's symmetric. So there is some central point. About that, the numbers are symmetric. Okay, all right. So now what else is given? The results reveal that 25% of the students scored 78% or more. So 25% of the students, meaning 1/4 of the students, have scored 78% or more. Is that clear? So what is this saying? 25% students scored 78% marks or more. So what does that mean? That means that if this number is 78%, so what is the number of people who have scored 78% or more? What is this area?
Or 25%.
25%, right? So that means the people who have scored 78% or more, this much area is, how much is this area? This area is 25%. Is that okay? Fine.
Yes.
Okay, what is the other statement saying? While 1/4 of these students, scored 30% or less. So, the people who have scored 30% marks or less than that, that number is also 1/4. Okay. So let's say, if this is 30%, so the people who have scored marks less than, 30% or less, what is that area? 1/4. 1/4 area meaning how much percent?
Or 25%.
Again, 25%. Okay, this doesn't look very symmetric. So let me just draw it like that. So let's say it is this much. So let's say this is 30%. So this area is also 25%. Okay. This is the information that is given to you. Now the question is, you have to determine the mean score of these students. So you have to find the mean value. Mean score of the students. And also the next question is, you have to find 10% trimmed mean if possible. Is that clear? Question is okay?
Yes.
Right? So basically, what are they telling you? That, I have 1.30%. The area to the left of it is 25%. I have one number 78%. The area to the right of it is 25%. So how do I find the mean value? So basically, I need to find this center value. Okay. Because this center, the point around which my distribution is symmetric, that is my mean whenever we have a symmetric distribution. Yes or no? Right?
Yes.
So if you are given exactly, this point and exactly this point, so they are symmetric, right? 25%, 25%. Both sides you have the same amount of area. So if you have to find what is the center point, how can you find it? You can take a,
Ma'am, 50% from both the sides.
okay, 50% of both the side would mean what?
Or 25% of that half area.
So 25% of this area. This area is,
No, that white area.
I didn't understand. Can you repeat once again?
Ma'am, it would be the left and right side of that symmetric line. 25%.
So how will I find the mean score? So there is a simple rule. Okay, there's a very simple, nice, beautiful rule, which is whenever you have a symmetric data, whenever you have a symmetric distribution, whenever you have a symmetric distribution, and let's say the symmetry is around this point. Okay, and if you have to find mean, so if this area is equal to this area, right? So whatever number you have here and whatever number you have here, if you use these numbers and just find the average of these two, that will give you this point, because this is exactly the midpoint of these two, right?
Yes.
If this distance is exactly the same as this distance, so then the mean will be the midpoint, right?
Yes.
And ab zaruri nahi hai ki this has to be 25% only. They would have given you, 30% area and 30% area. Then also it would have hold valid. So basically any 2 points that you pick which are equidistant, and then you just take the average of these two, that will give you the mean only, right?
Ma'am, then what if we had different percentages on both sides?
So then you can't do anything. Then I don't know. Because I know that if I have the exact same area here and exact same area here, this position is exactly similar to this position because it is symmetric, right?
Yes, ma'am.
So this point and this point, if I just take the average of these two, this will give me this center point. But if let's say this would have been 20% and this is 25%, then I don't know. Then we can't say anything. But only if it is symmetric, you are going equal distances on both sides. So if you just take the average of these two, you will get the mean value. Is that all right?
Yes, ma'am.
So how do you find the average in this case?
+78 30/2.
Exactly. So the mean score would be 78 plus 30 divided by 2, which is how much? This is 108 by 2. Yes, which is 54, right? So 54%. This is the 54% answer. 54% is the mean score of students in this particular situation. Is that all right? Fine.
Yes.
Okay. So if this is clear, then you have to tell me, can you find 10% trimmed mean of this data? First of all, tell me what is 10% trimmed mean means. What will 10% trimmed mean would mean? What is a trimmed mean?
Ma'am, we will remove the 10% data from left and right side both. And then we will calculate.
Exactly. So if this question is saying you have to remove 10% points from the left side and 10% point from the right side. Exactly. Right? So let's say this is 10%. This is 10%. This is exactly the same. This will be symmetric to this side also. This is 10%. So what is this? What are they asking you? That please cut off this data and then find the mean. Please cut off this data. Please remove this data. Please remove this much data and then find the mean. So if you remove 10% on one side and 10% on the other side, does the data loses symmetry? Or it is still symmetric? So let's say if I remove this, does the data maintains the symmetry or it loses symmetry?
Ma'am, it maintains the symmetry.
It is still a symmetric distribution, right? So what will be the mean?
Ma'am, 44%.
44. How 44?
Okay, what? Ma'am, I have minus 30%, minus 10%, and plus 68% upon 2.
Okay, why are we removing 10%? जो ये डेटा है इसका मीन क्या होगा? ये यही वाला पॉइंट रहेगा ना इसका मीन?
Yes, ma'am.
जो पॉइंट ऑफ सिमेट्री है. तो जब आपने यहाँ से when you have removed 10% data and when you have removed 10% data here, has the center point through which, like about which the point is the data is symmetric, has that point changed?
No, ma'am.
It is still at the center only, right? So what is the trimmed mean? What is the 10% trimmed mean?
54%.
54%.
Still 54%. So you can keep saying, please remove, find 25% trim mean, find 10% trim mean, find 8% trim mean, any percent of trim mean you ask. What is going to be the answer all the time?
54%.
4% only. So what does this tell me? That if my data is symmetric, right? And whatever trimmed mean you ask me to find, that is going to be that is going to be exactly equal to what?
Original mean.
Perfect. So any trimmed mean that you find will be equal to the original mean, meaning mean of all the data. Is that okay?
Yes.
Right? Why? Because it is symmetric. The point of symmetry is not changing. Chahe you remove this much, it's still the same. Chahe you remove this much, chahe you remove this much. Whatever percent of trimming you do, it doesn't really matter. Right? That is okay. Are we clear with this?
Yes, ma'am.
Perfect. All right. So, all right, let me just grab one or two more questions related to this particular chapter. So there is one question also, how is your sample variance different from the population variance? Explain using the concept of degrees of freedom. So, that degrees of freedom discussion that we had. So you have to use that particular discussion here. Okay. All right, let me just grab two more questions now from the all right, okay. So we have two more questions. Let's see what are they. So these two questions are from your current paper, like 2023, just the previous batch, which is the one which will be relevant for you. So that is there. Okay. All right. So let's see. So this is one question that we have. And this is another question that we have. First, let's do the second problem. Okay. So this is from your 2023 paper. All right. चलो जी करते हैं फिर पहले इसको करते हैं then we will move on to this. Fine. Okay. So ठीक है. So the second problem is saying find 27% trimmed mean of these numbers. And then the question is, what would be the trimming percentage if one observation is removed from each end of the data set? If you just remove one observation from each data set, what is the percentage of trimming that you are doing? What will you call it? What percentage of trimming are you doing? ठीक है? So सबसे पहले, what do you have to do? Tell me. 27% trimmed mean मतलब 2, 4, 6, 7, 11, 21, 81, 90, 105, 121. All these numbers are there, right? So how do I proceed then? What should we do?
मैम नंबर ऑफ ऑब्जर्वेशन जैसे 10 है तो 10 का 27% निकालेंगे.
So number of observation is 10. Very nice. N is 10. So we find 27% of 10. What is that? 2.7.
Yes.
Now what do we do? 22.7 is between what two integers?
2 and 3.
Right? So then what do you do? So
2
first,
into alpha plus 3 into 1 minus alpha equal to 2.7.
very nice. So basically first you will find trimmed mean by removing two observations on both sides, right? Yes.
Yes.
And also, you will find the trimmed mean by removing three observations on both sides. Here you will find the trimmed mean by removing three observations. Yes.
Yes.
And then you will take a weighted average, which is 2 times alpha plus 3 times 1 minus alpha. That should give you 2.7. So what should alpha value be? 2 alpha plus 3 minus 3 alpha is equals to 2.7. So here 3 minus alpha is 2.7. So what is alpha? 0.3, right? So we know how much weightage we have to give to each of the mean, right? So what is the trimmed mean that when you remove two observations? So when you remove two observations, what is the mean that you are going to get? So you remove these two and then these two. What do you get? Can you calculate it? Let me also do it. So please take a calculator with you because in your paper, because it will be needed all the time. So the total sum that I'm getting is 216. And how many observations we have now after we've removed 4? It is 6, right? So what do we get? 36? Yes? Are you also getting the same?
Yes, ma'am.
Okay. Now, trimmed mean when we remove 3 observations. What do we get? So I have to remove 6 and 90. So basically I have to remove 96 from 216. What do I get? I get 120. And how many observations are left? 4 only. So divide by 4. What do I get? 30. Right? Are you also getting the same?
Yes, ma'am.
Okay. Now what do you have to do? You have to give a weight of 0.3 to this and 0.7 to this, right? So you have to, your trimmed mean X bar 27%. What is that going to be? 36 should be given a weight of 0.3 and 30 should be given a weight of 0.7, right? And then you add them. So what is this? What is 36 times 3? 108. Yes. And then you put a decimal here plus 30. So this is basically 721, right? So if you add them, what do you get? 31.8. So your trimmed mean 27% is actually 31.8, right? Is that okay?
Oh, yes, ma'am. Ma'am,
Okay.
will the calculator be allowed in the examination?
Yes, definitely. So let me show you the. Can you see my screen?
Yes, ma'am.
So इसमें जो आपका फ्रंट पेज होता है उसमें लिखी होती हैं चीजें. So write your roll number, blah blah blah, all intermediate. Use of simple non-programmable computer is allowed. ठीक है, तो कैलकुलेटर इज अलाउड, ठीक है, बट वो बहुत ज्यादा साइंटिफिक और वो सब नहीं होना चाहिए. बेसिक जो हमारा नॉर्मल कैलकुलेटर होता है वो अलाउड है. ऑल राइट. ओके, सो इसी क्वेश्चन में देयर इज वन मोर पार्ट which is asking us something. So let's see what that is. Okay, so that was the first part, finding 27% trim mean. So that we have found. Now, they are asking what would be the trimming percentage if one observation is removed from each end of the data set. What is the question saying? Can you explain it to me? Read the question once again and tell me what is it trying to say.
10%, ma'am.
Very nice. Yes, go ahead, Anshika. Go ahead.
मैम इसमें वो जो ये जो मीन है बीच का, ये ट्रिम मीन वो सेम आना चाहिए, और अगर दो ऑब्जर्वेशंस को हटा दे तो फिर क्या परसेंटेज आती है उसकी?
सो बेसिकली एक्चुअली ये लोग क्या बोल रहे हैं, जैसे जब देखो, जब 27% ट्रिम्ड मीन था तो आपने क्या किया था, आपका नंबर आया था 2.7, तो अब 2.7 ऑब्जर्वेशंस तो आप रिमूव नहीं कर सकते, तो यू रिमूव 2, यू रिमूव 3 एंड देन टेक अ वेटेड एवरेज. बट मान लो दे वुड हैव डन 30%, so 30% would have given us number 3, right? So that would have meant I have to remove 3 from this side and 3 from that side. So they are asking what percentage should I trim so that I have to remove 1 from left and 1 from right. So what should be my trimming percentage so that I have to remove 1 observation from both sides. So basically they are asking what should I give here so that that percentage of 10 is going to be 1. That is the question, right? So what percentage should I have of the trimming so that that percentage of 10 should be 1. So what percentage of 10 is 1? So basically, x% of 10 is 1. So what does that mean? X divided by 100 times 10 is equals to 1. Yes. So what is x? 10? Yes or no? Right?
Ma'am, I am not able to understand this one. Could you please?
Yeah, definitely. So my question to you is, मैं क्या बोलूं आपको कि आप कितनी % ट्रिमिंग करो कि मुझे इधर लेफ्ट साइड से एक ऑब्जर्वेशन रिमूव करनी पड़े और दूसरी साइड से भी एक ऑब्जर्वेशन रिमूव करनी पड़े. तो जब हम when we remove observations, how do we remove observations? We find whatever percentage I tell you. Let's say I give you 30%. So what do you do with this 30%? You do 30% of 10 and that is giving you 3. So what you do is you remove 3 from both sides, right?
Yes, ma'am.
So they are asking what percentage should I tell you to trim so that this percentage of trimming turns out to be 1. Then you remove 1 from both sides. So they are asking what is this percentage?
Okay.
Okay.
Go.
Let's say this percentage, let's say this percent is x. So x% of 10 should be 1. So what is x%? You write it by x by 100 times 10 equals to 1, right? So what is
Yes.
x value? 10.
10.
Now you can see, if I tell you, you have to find 10% trimmed mean, what will you do? You will take 10% of 10, which is 1. So then you'll remove 1 from left and 1 from right.
Yes.
Yes, that's the question. Okay? So that percentage should be 10%. Okay? All right. So this is clear how to do this?
Yes, ma'am.
Fine. Chalo. Now moving on to the next one. Let's do this. Okay. So what is this? So let's read the question and let's see what it is asking us. First, what are they saying? The test scores of 8. Okay, test scores out of 800. So there was some exam. So out of 100, what is the test scores that students have received of a competitive exam of 2 groups of 15 students? So there were 2 groups, group 1 and group 2. For group 1, these were the marks that students have received. Some people have received 10 marks also. Some people have received 790 marks also. And then there was another group. For that group also there are 15 people. And then how many marks they have scored, that is given in this list. This data is clear? So out of 800, how many marks students have scored for each of the group, each of the 15 people in the group, that is given to us. And after that, what is the question that is getting asked? The question is, you have to find the median, you have to find the first quartile, you have to find the third quartile for each group. So first quartile is, what are the points, to the left of which there is 25% data. So first quartile is basically your lower fourth. Lower fourth. What is your third quartile? Third quartile is basically your upper fourth. Okay. So actually, whenever you have data, it can be divided into, this is 50% data. So that means 50% data is towards the left, 50% data is towards the right. And this point is called median, right? This is called median. Whenever you say this is my first quartile, that means 25% of data is on the left and 75% data is on the right. So this is actually first quartile. Quartile meaning 25%. So first 25%. Median is actually sometimes also called second quartile. Okay. And then the third quartile. Third quartile is what? It's that point to the left of which you have 75% data and to the right of which you have how much data? 25% data. Okay. That is how everything is. Is that clear?
Yes.
So this is actually your lower fourth. When we were doing box plot, this is lower fourth. And this is your upper fourth. Okay, so lower fourth and upper fourth. So that is asked from you. You have to find the median, first quartile and third quartile for each of the group, for group 1 also and group 2 also. And now the next question is, are there any extreme or mild outliers in both groups of data? So you also have to, tell if you have any extreme outliers or if you have any mild outliers. So now remember, we have to think in terms of the box plot. How did we used to define outliers? We will first find what? We will find which spread we will find?
Fourth spread.
We will find fourth spread. So fourth spread. And then what we will do, whatever is my, upper fourth, whatever is my upper fourth, I will add 1.5 Fs to that. I will do upper fourth plus 3 times fourth spread. I will also find 2 more points. What is my lower fourth? Minus 1.5 Fs. Lower fourth minus 3 times Fs. And then I will see if there are points which are lying on that or not. Is that okay? For both the groups individually. So what I will do is, I will do the question for one group, and then for the second group, you have to follow the same process. Is that okay?
Yes.
फाइन, चलो जी. तो सबसे पहले हम लोग शुरुआत करते हैं मीडियन निकालने से. मीडियन, देन लोअर फोर्थ, देन अपर फोर्थ, देन फोर्थ स्प्रेड, देन आउटलायर्स. So let's just pick this data now, the first group. So this is my first group data. Okay, fine. How many observations are there? 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What is going to be my median here? Which observation?
Eighth observation.
Eighth observation. And that is 95. So my median value is 95. Okay. Now what do you do? To find the lower fourth and upper fourth, what should we do? I have to divide my data into lower half and upper half, right? What will be lower half and upper half? If the data is odd, what should you do?
From 1 to 8 and 8 to
15 plus 1 upon 2.
15.
8.
So this will be my lower fourth and this will be my upper fourth, right? Yes or no?
Yes.
This eighth observation will be included in both, right? Okay. So now in this data from 1 to 8, 7, yeah. So I have 8 observation, 1, 2, 3, 4, 5, 6, 7, 8. Yes. Right. So yeah. Yes. So how do we find the mean here? I mean median here? What will be the lower fourth here? So how do you find lower
mean of
fourth?
4th and 5th observation.
So mean of fourth and fifth observation, what is that? 15 plus 35 divided by 2.
25.
Right? So that will be 25. Lower fourth is basically whatever is your lower half, you find the median of that. So here the median will be the average of these two observations. So 15 plus 35 is how much? 50 divided by 2, which is 25, right? And what is the upper fourth now?
455.
So basically these observations. And what do we have to do here? We have to take which observations? So 3 you remove from here, 3 you remove from here, 11th and 12th. And then these two you have to average. So what is the average of this? 490 plus 420 divided by 2. So what is that going to be? 910 divided by 2, which is how much?
455.
2, right? So this is 452. This is fine so far.
Yes.
ठीक है, लोअर फोर्थ निकाल लिया, अपर फोर्थ निकाल लिया, फाइन. अब इसके बाद हमें क्या निकालना है? सो बेसिकली दिस इज योर फर्स्ट क्वार्टाइल, दिस इज योर थर्ड क्वार्टाइल. Okay, now, and median you have already calculated. Now after this, what are you supposed to find? You will
Ma'am,
find,
it's 455, right?
yeah, it's 455. 910 divided by 2, yes, 455. So now what do you find? Fourth spread, which is upper fourth minus lower fourth, which is 455 minus 25. What is that going to be? 430. Yes. Right?
Yes.
Okay. So now I have different observations. I have to find this. I have to find multiple points. This is my median. This is upper fourth. This is lower fourth. I have to find what is this point, upper fourth plus 1.5 fs. And I also have to find what is this point, upper fourth plus 3 fs. And then I have to find what is lower fourth minus 1.5 fs. And I also have to find what is lower fourth minus 3 fs. And that will tell me, that will help me in bifurcating. Do I have mild outliers, or do I have extreme outliers, or do I even have outliers to begin with? Okay, so I know this. I know this. I need to find these 4 values. So first of all, what is 1.5 times Fs? 430 times 1.5. What is that? And I also have to find 3 times Fs. So what is this value? 0, 9, 12. And what is this value? 645, right?
Yes, ma'am.
ठीक है, तो मुझे ये पता चल गए. ठीक है, अब मुझे क्या करना है, ये वाला नंबर ऐड भी करना है और सब्ट्रैक्ट भी करना है. सो बेसिकली आई हैव टू फाइंड दिस अपर फोर्थ प्लस 1.5 टाइम्स Fs. व्हाट इज माय अपर फोर्थ? 455. व्हाट इज 455 प्लस 645? This is something, this is actually 1100, right?
Yes, ma'am.
And upper fourth plus 3 times Fs, that is going to be 455 plus 1290, which is nothing but 5, and then 5 and 9, 4, 1, 6, 7, 1, right? And what is lower fourth minus 1.5 Fs? My lower fourth is what? 25. So what is 25 minus 645? It will be something negative. And again, what is lower fourth minus 3 times Fs? It will be 25 times 1290. It will be something negative only, right?
Yes.
So tell me, without looking at the data, is it possible for your numbers, if your exam is out of 800, can your marks be negative?
No.
Your marks can't be negative. Can your marks be greater than 800?
No.
So is it even possible to find the, is it even possible to have outliers in this case?
No, ma'am.
No, because your number has to be greater than this to be called a mild outlier. Your marks can't be greater than 800. Your number has to be greater than 1745 to be called an outlier, an extreme outlier. But your marks can't go greater than 800. Similarly, here to be called a mild outlier, it has to be less than this. But numbers can't be negative. Similarly, here it should be negative. So is it possible? Are there any extreme or mild outliers in this case?
No, ma'am.
So the answer is no. Okay. No. Not possible in the first group. First group may not possible. But why is that happening? Because your fourth spread is very high, right? Your fourth spread is 430. If your fourth spread would have been something very small, let's say your fourth spread would have been 10, okay, in that case, would it be possible for us to have outliers? So let's say, for example, I'm just giving random example, let's say Fs would have been 10. So what is this? 10 times 1.5, 15, and what is this? 30, right? So you will just have to add 455 plus 15 and then 455 plus 30. So that will be well within the range, right?
Ma'am, for the positive numbers, 1100 and 1745 could be considered as outlier.
नो, सो बेसिकली आपको क्या देखना है कि क्या कोई आपका ये जो नंबर्स दिए हुए ना, इसमें से क्या कोई ऐसा नंबर है जो 1100 से ज्यादा है? सो जो भी नंबर इससे ज्यादा होंगे वो माइल्ड आउटलायर, जो इससे ज्यादा होंगे वो एक्सट्रीम आउटलायर, जो इससे नीचे होंगे वो एक्सट्रीम आउटलायर, जो इससे भी नीचे होंगे वो माइल्ड आउटलायर्स, जो इस रेंज में वो माइल्ड, जो इस रेंज में वो एक्सट्रीम, जो इस रेंज में वो माइल्ड, जो इसके बियॉन्ड वो एक्सट्रीम. तो हमें ये चेक करना है, डू वी हैव पॉइंट्स विच आर इन दिस रीजन? बट ये वैल्यू तो 1100 आ गई, बट मेरे मार्क्स तो 800 पे ही आके रुक जाते हैं, राइट?
यस मैम।
तो मैं तो कभी वहां जाऊंगी ही नहीं.
यस।
So in this case, it's not possible. And so I'm telling you the reason why this is happening, because आपका फोर्थ स्प्रेड बहुत बड़ा है और उसका 1.5 टाइम्स तो और भी बड़ा हो जाता है, राइट? बट अगर ये फोर्थ स्प्रेड बहुत छोटा होता, लेट से 10 होता, तो ये वाली वैल्यू 15 होती, ये वाली वैल्यू 30 होती. और जब आप इसमें 15 और 30 ऐड करते तो आपको रीजनेबल नंबर्स मिलते. यू वुड हैव रिसीव्ड रीजनेबल नंबर्स. सो इट विल बी 470. So is there any number which is greater than 470? Yes, this number is there, this number is there, this number is there, this number is there. So these numbers would have been your outliers, right? If that would have happened. Okay. But right now that is not happening. So you have to do similar things again for the next question as well. I mean, for this.
Ma'am, what was whiskers in box plot?
Okay, whiskers, fine. Let me just go to that. Okay, first of all, let me just wrap this up. This is okay?
Yes, ma'am.
Fine. Chalo, let me show you the whiskers now. I think yesterday also you asked this, right?
Yes, ma'am. I forgot.
No worries, no worries. Um,
Ma'am, also when we draw histogram for qualitative data, should we start it at a distance of 0.5 before the 0?
it's usually considered nice if you do that because there is some space from the vertical axis. Yes.
Okay, ma'am. Ma'am, and then we should not leave any gap between the rectangular bars, right?
You can, if there are 2-3 categories, you can. Actually, there is no point because there is no meaning to the axis, na? There is no number attached to it. So you will just have some categories, A, B, C, D, right? So you can
Yes,
leave gap. That is fine.
But for histogram, can we leave the gaps?
If you are drawing histogram for quantitative data, you should not. If it is for qualitative data, you can.
Okay, ma'am.
All right. So basically, this is called whisker. So what is this term whiskers typically used for? Have you ever heard of this term before?
Cats.
So cats की जो क्या बोले उसको mustache उसको whiskers बोलते हैं, right? They are very long. So it's like so when you draw the box plot, so there is one line here, there is one line here which is the median, there is one line here which is the upper fourth, and these line that you extend, they are called whiskers. These lines that you extend from lower fourth to the smallest point and this upper fourth to the largest point, these are called whiskers.
Okay, ma'am.
These two lines are like the whiskers. Okay.
Yes, ma'am.
That's all. No, nothing else.
Okay, ma'am.
All right. Okay, fine.
Ma'am, there is a comparative box plot. We have to draw it in the same way or in any different way.
So, okay, comparative box plots के लिए आपको क्या करना है? देखो, जब आपके पास ऐसी सिचुएशन आ जाए जब आपको, जैसे हमने मोस्टली बॉक्स प्लॉट किस तरीके से बनाए हैं, when we are just given one set of data. What if, let's say, For example, like the example that we had in this case, there are two groups, and in each of the group you have people scoring different marks. So now you know what is the minimum value of your score 0, what is the maximum value of your score 800, right? And you can represent both these points, like both the box plot in the same diagram, right? So whenever you have similar situations, you can make box plot in the same diagram. And when you do that, it's called comparative box plot. So you are comparing two box plot, which are kind of explaining the same situation. So here, let's say, for example, in this case, they have some cancer radon related concentration data. So for the people who have no cancer and the people who have cancer, so they have two categories. And then they've drawn, their box plot like this. So on the y-axis, they have different numbers. So then this is the median. This was the lower 4. This was the smallest value. This was the median. This was the upper 4. This was the largest value, which was not the outlier. And this was the outlier, right? Similarly for this. That's all. Nothing else.
Okay.
जब दो situations, when you have two different groups or categories for which you have to represent similar set of data, then you can use comparative box plot. So it's just a situation of representing similar situation in the diagram, in the same diagram. So like, how does it help? It tells you that, okay, radon concentration for the people who have no cancer is a little spread out. For the people who have cancer, it is a little concentrated, because you see this box is very squeezed, right?
Yes.
And then you can see if there are outliers or not. So that's basically all that we have here. All right.
Yes.
Any other doubts? Any other questions from this?
Ma'am, how we can segregate the stamp and display in case of decimal? For example, if there is 3.48, so
3.4.
we will take it as 348 and then segregate into stamps and leaf.
Actually, you will have to see what are other data points. Just by looking at one point, you can't tell. You have to see what are how are other points distributed. So like if you have all the points जहाँ पे एक point है decimal के आगे और 2 point है decimal के बाद, ठीक है? तो आप क्या कर सकते हो? Then you can write 3.4, or you can write 3, 4, and then 8 could be leaf. 3, 4 could be stem. 3, 5 could be stem. Other point could be leaf. And then in the stem area, you can write 1 point before decimal and 1 point after decimal, like that. So you will have to see how all the other points that you have to plot, how are they?
और मैम एग्जाम में जो बाकी पॉइंट्स होते हैं वो सेम मिलेंगे ना, जिसमें और राइट ऑफ लेफ्ट में पॉइंट्स के बाद एक
सिमिलर जैसे मान लो ये वाला क्वेश्चन है, दिस वन 44. इसमें सारे पॉइंट्स मेरे को कैसे दिख रहे हैं? देयर आर 2 पॉइंट्स बिफोर डेसिमल एंड 1 आफ्टर डेसिमल, राइट?
ओके.
So what I can do here is I can see that let's say if I do this, if I do 2 decimal points, so like 2 points before decimal, if I write that as my stem, then what happens? I will have numbers 29 as stem, 49 as stem, 30 as stem, 28, 28, 26, 33, 29, 23, and 31. But what is the problem here? The distance between them is very big, right?
Yes.
Suddenly there is 49. So what will be a good idea here? That you can see the first digit, the tens place, it's 2, 4, 3, 2, 2, 2, 3, 2, 2, 3. So 2, 3, 4, maximum these 3 values are there. So it's usually a good idea to put 2 and 3 and 4 as the stem. And whatever is left, you can put it as leaf. So as leaf, you can write 95, 93, 06, like that.
Okay.
So you have to kind of see कि stem के बीच में बहुत distance ना आए, stem के बीच में ज़्यादा distance ना हो, और leaf आप जैसे भी आपकी बन रही है, after you've put stem, you can write, and in a small legend, a small label, write what is stem. So यहाँ पे stem would be the tens place digit, and leaf would be the first ones and 1 point after decimal. So that you mentioned, that's all. Okay.
Okay.
All right. Any other doubts from this?
No, ma'am.
Chalo ji. So we are wrapped up with the first chapter, first introduction. This was actually your first unit. Isme se we will have a weightage of 15 marks. Okay. So practice it well. Jo bhi doubts hai, keep asking on the group. And now let's take a break. And after break, we will start probability. Okay, which is your next chapter, chapter number 2. All right. So it's 7:11 right now. Let's continue at 7:22. Let's start at 7:22. Thank you, guys. All right. So first of all, why do we need to understand probability? Because probability is actually the link which will help us in defining, what are the later concepts that are going to come, which is random variable. Okay. So probability ke basic concepts we need to understand to be able to map from, events, sample space and everything to real numbers. Okay. Chalo. A little bit of probability you must have done in your class 12 at least. Narmada, in applied mathematics you had probability or not?
Yes, ma'am, we had probability.
You had. Okay, chalo. All right. Irrespective, we will just do it from the basics. So even if you do not have any background in that, it's fine. All right. So there are a few terminologies that we need to understand, few basic definitions. Let's see that. So first of all, there are a lot of terms that you will keep hearing again and again. So it's good that we understand what do we mean by those terms. So the first term is experiment. Okay. So what is an experiment? An experiment is any activity or a process whose outcome is subject to uncertainty. What does that mean? So any experiment, you say that I am doing this experiment. So that means when I perform that experiments, what is going to happen? What is going to be the outcome of that experiment? That is not certain. Okay. So that is not going to, so we actually don't know if that event is going to happen or not with certainty. Okay. For example, what can be an experiment? Let's say I roll a die. Let's say my experiment is that I roll a die. So when you roll a die, what happens? So a dice or die, whatever you call it. So when you roll a die, what can happen? Do you know what number is going to come? With certainty. No. We know that, 1 can come, 2 can come, 3 can come, 4 can come, 5 can come, and 6 can also come. So because I don't know what is going to be the outcome of this experiment, I roll a die. Anything can happen. From 1 to 6, any number can be on the dice, right? So that is an experiment because the outcome is uncertain. Okay. For example, what else? Tossing a coin. This is also an experiment because when I toss a coin, what can happen? What could be the outcomes? Let's say head come on top or tail can also come on top, right? Me giving my exam, which is a 100-mark paper, is that an experiment? Yes, because it can happen that I can get 0 marks, 1 mark, 2 mark. If the teacher is like, they give half marks, so 0.5 is also possible. 99.5 is also possible, 50.45 is also possible. So there are multiple possibilities of how many marks that you can score in that particular exam, right? So all these are examples of experiments. So any activity or process whose outcome is subject to uncertainty, that is called an experiment. Okay. All right. Is that fine?
Oh, ma'am, the giving exam will also include an experiment.
Yes,
As if
that is also an
the
experiment. Yes. So, like if let's say it's an entrance exam, so the whatever score that you get, the outcome could be whether you clear that paper or you don't clear that paper, right? Whether you
yes,
get selected or not get selected. Okay, what else could be the examples? Multiple things. Any activity whose outcome is subject to uncertainty would be called an experiment. So, like you sit for placements, you will get a job or not get a job, right? Anything for that matter, right? You go to a shop, whether it will be closed or it will be open, right? Multiple things can happen. So there is no uncertainty. There are, and there, wherever there is there is certainty, that is something which is definitely going to happen, and that is something that we do not call an experiment. There, today, time will cross 8 p.m. So that's something which is definitely going to happen. There is no uncertainty about it, right? So that is not an experiment, whether time today will 8 p.m. happen or not. Okay. So something like that. So experiment is something whose outcome, it's a process or an activity whose outcome is subject to uncertainty. Okay. All right. Because you have uncertainty, that means there are multiple possibilities that can happen. Okay. So when you put all the possibility, when you list down all the possibilities, that is called sample space of that experiment. So what is a sample space? The sample space of an experiment. What is a sample space? So whenever you talk about sample space, it is related with an experiment. So what is the sample space of an experiment? So sample space of an experiment, which is denoted by, sample space is denoted by S, is nothing but it is the set of all possible outcomes of that experiment. So whenever you do an experiment, there are multiple things which are possible. And if you list down all the possibilities of that experiment in a set, you call it a sample space. Okay. So for example, in this experiment, when I was rolling a die, what are the possible outcomes? Possible outcomes are, 1 can come, 2 can come, 3 can come, 4 can come, 5 can come, 6 can come. So what is this? This is a sample space for my experiment that I am rolling a die. Okay. If my experiment would have been to toss a coin, then what would have been my sample space? Whether head comes on top or tail comes on top. If my experiment is, if I toss a coin 2 times, then what is my sample space? It can happen that first time head comes, second time also head comes. First time head comes, second time tail comes. First time tail comes, second time head comes. First time tail, second time also tail, right? So that is a sample space for the experiment that I'm tossing a coin 2 times. Okay. So this is the definition of sample space. Is that clear?
yes, ma'am.
Right? Okay. Now we have another definition, which is what is an event? What is an event? So an event is any collection of, collection meaning subset. So an event is any collection or a subset of the outcomes which are contained in the sample space. Okay. So what is an event? An event is nothing but a subset of your sample space. So let's say, this is my, let's say my experiment was rolling a die. This was my sample space. And any subset of this will be called an experiment. So let's say one subset could be, getting 1, 2, 3. So this is an event. One of the subset could be 2, 4, 6. So this is also an event. One could be getting 5 and 6. One could be getting just 5, right? So all these subsets that I have for this sample space, they will be called an experiment. Okay. So they will be called an event. Any subset of the sample space would be called an event, right? And there is another definition, which is an event is called a simple event. So the event that we have, it could be simple or it could be compound. So an event is simple if it consists of exactly one outcome. So if I have an experiment like this, if I have an event like this is a simple event because there is only one outcome in this. Okay. And it is called compound if it consists of more than one outcome. Okay. So an event is a simple event if it consists only of a single outcome. It is called compound if it is having more than one outcome. Okay, I have a question for you. Can a null set be called an event? Can a null set be called an event?
No, ma'am.
Why?
Because ma'am, there if an experiment is conducted, there is any outcome will happen. This is sure.
Okay. So event is basically a subset of sample space.
It can be an event, right?
Is null set a subset of any set?
Ma'am, we say that the chance of getting 7 on throwing a die, it's 5, right? But
Yes.
it's an event.
Yes. So basically, because whenever you take a subset, phi null set is a subset of all the sets, right? So because null set is a subset of all the sets, so we can have an event which has no element in it. So let's say one event could be that if you get a 7 when you throw a die, is that ever going to happen? No. It is an event, but it is an impossible event, right? That is something which can never happen. All right. Yes.
Yes.
And can the entire sample space be called an event? Can we call
Yes,
it?
ma'am.
Okay.
Yes.
Because, there could be situations. The entire set is also a subset of itself, right? So let's say I call that when I throw a die, if my event is if I'm getting any real number or not. So if you throw a die, definitely you're always going to get a real number, which is 1, 2, 3, 4, 5, or 6. So that is also an event. So entire sample space is also an event, and null set is also an event, right? So that is also the case. Okay. All right. So an event is basically any subset of your sample space. It is simple if it has exactly one outcome. It is compound if it has more than one outcomes. All right. So there could be multiple events. So, in this case, let's say if I throw a die, I get 1, 2, 3. That event is getting 1, 2, 3. If I throw a die, I am getting an even number. That is also an event. If I throw a die, I get a number which is greater than 4. 5, 6. This is also an event. If I throw a die, will I get a number which is divisible by 5? Yes, this is also an event, right? Will I get a number greater than 8? So that is also an event which is having no element. It is 5, right? So you can have situation.
Ma'am, so each element in the sample space is a simple event.
Yes, if you just write 1, 2, 3, 4, 5 as sets, they are simple events. Yes.
Okay.
So in this case, simple event example would be getting 1 or 2 or 3 or something like that. So that will be a simple event. Okay. All right. So
Yes, ma'am.
since we say that event is basically a set only, right? Since an event is a set, so all the mathematical set operations that we have of union, intersection, minus, symmetric difference, complement, everything that is applicable here. Because event is a set, so set operations and results can be used to study the event. So because event is a set, so any set related operation can be used to study events, multiple events. All right. So far so good. All the definitions are fine.
Yes.
Okay. So more definitions coming up. First is, what is the complement of an event? Okay. The complement on an event A. Let's say I have an event A, and the complement on that event A, which is represented by A prime, is the set of all the outcomes in my sample space that are not contained in A. So what is the complement of an event A? It is basically set of all possible outcomes in my sample space which are not in A. So this is exactly how we define complements, right? So let's say I have an event A which has two outcomes, 5 and 6. And if my experiment is rolling a die, so what will be A complement? If my sample space is this, what is my A complement going to be in this case?
1, 2, 3, and 4.
Perfect. 1, 2, 3, and 4. All right. So this is A complement. All right. Fine. Okay. So this is complement. We can also define union of events. So let's say the union of two events, A and B, which is also denoted by A union B. So A union B, because A union B is also a set, so that is also an event. A is an event, B is an event, right? A union B is also a set, so this is also an event. So A union B is an event, is the event which consists of all the outcomes. It consists of all the outcomes that are either in A or in event B or in both the events. Okay, this is the union of two events. Again, the way we define union of sets, it's exactly like that, because event is a set, so union of set is exactly how you define it. All right. Now, intersection of set, intersection of two events. The intersection of two events, A and B, which is denoted by A intersection B, because A intersection B is also a set, so that is also an event. This is the event that consists of all the outcomes that are in both A and B. So all the outcomes which are both in A and B will be in the event A intersection B. So that is the definition of intersection. All right. So far, so good.
Yes.
चलो जी, okay. अब उसके अलावा there is something called a null event. ठीक है, because there is a null set, so we have to define something called null event. So let phi, this is phi, let phi denote the null event. And what is a null event? Null event is basically an event which consists of no outcome whatsoever. Okay. So let's say, my experiment was rolling a die. One of the event was getting an even number. The other event is getting an odd number. Right? So what is this set? 2, 4, and 6. What is this set? 1, 3, and 5. And if I do A intersection B, what am I going to get?
Ma'am, the whole sample space, that is 1, 2, 3, 4, 5, 6.
I am doing
Null event.
right?
Null set, yes.
है ना?
That is
Intersection कर रहे हैं. So intersection कर रहे हैं तो nothing is in common, right? So whenever A intersection B is phi, what do we call? We say that A and B, they are said to be mutually exclusive. So if, there are two events, and if you take the intersection and it comes out to be a null set, we call that these two events are mutually exclusive. They are mutually exclusive. They have nothing in common, right? And you can also call them disjoint sets or disjoint events. So these two events, they are mutually exclusive. They have nothing in common. They are also called disjoint events. They have nothing in common. Okay. So that is the definition of mutually exclusive, or you can say disjoint events. Both of these terms mean the same, that their intersection is null. Okay. All right. So, let's say this is my entire sample space, and I have an event A and I have an event B. Because they have nothing in common, they are all separate. So this A and B, they are called mutually exclusive events. Is that all right? ठीक है?
yes.
ठीक है, चलो. So basically, these were some of the definitions that we needed to know. So what is an experiment? It's any activity wherein the outcome that is going to happen is uncertain. When you list down all the outcomes of an experiment, you call it a sample space. What is an event? Any subset of a sample space is called an event. An event is simple if there is only one outcome. If it has more than one outcome, it is called a compound event. What is the complement of an event? Just include all the members from sample space which were not in that event. Union, if you have two events, take which is in A or in B or in both. Intersection, which is in both. and mutually exclusive or disjoint events, meaning those two events have nothing in common. Okay, so these were the definitions which we would be needing throughout. So that should be clear to us. So far, are we all good? ठीक है?
Yes.
चलो जी, अब हमें ये समझना है, we have to understand there is something called axioms. There is something called axioms. Do you know what is the meaning of an axiom? Have you ever?
No.
Yeah. What is an axiom? No? Yes?
The basic things which we do not have to prove, means it's already there.
Very nice. So basically, you know, if we study maths, right, what is the most basic thing? We say that 1 means 1, 2 means 2. If you start questioning that why are you writing 1 as 1, why are you writing 2 as 2, why is 1 plus 1 2, why is 2 plus 2 4, if we start questioning these things, we can never study maths. Is that correct or no? And
Yes.
at some point of time, everybody must have thought about it. Why is 1 plus 1 2? Why is 1 plus 1 not 3? From today onwards, I want to call it 1 plus 1 is 3, right? So what is an axiom? Axiom is like, you know, the foundations that you assume to be true. You do not have the burden to prove that, okay, this is true. So if you write 1 plus 1 equals to 2, there is no need for you to prove it. You have to assume that 1 plus 1 is 2. Okay. So axiom is anything which is so basic that you have to assume that this is assumed to be true. So there are some basic assumptions on which everything is built. So there is some foundation and everything is built on that foundation, right? So those foundations or those basic things which you do not prove and you just assume that this is the case, those are called axioms, right? So those are axioms. So to study probability also, we have some basic assumptions that are there, some basic axioms of probability, right? So we have 3 axioms which we can't question why is that the case. Okay. So because if you start questioning that, we can't move forward and we can't study probability at all. Okay. So those 3 axioms, what are those 3 axioms of probability? We will be studying that. Okay. And why are axioms made? They are made so that intuitively things can make sense, because if you do not assume them to be true, intuitively everything will fall down. Made so that intuitive sense or notion holds. All right. So now what we are going to do, we are going to understand what are some axioms of probability. Anything else that you see in probability can be proved using these 3 axioms. So these axioms, these are your assumptions that you use to move forward in the field of probability. Anything else, any other result that you see can be proved using these 2 axioms, these 3 axioms. Okay. So what are these axioms? Axiom 1. So first axiom is, whatever experiment that you are doing, and from that experiments, you will get multiple events, right? So first axiom is, for any event A, probability of that event A is going to be greater than or equal to 0. So whatever event that you have, the probability of that event has to be either greater than or equal to 0. This is my first axiom. So no event no event can have a negative probability attached to it. Okay, this is my first axiom. Is that fine?
Yes.
So what is my second axiom? My second axiom says the probability of your sample space is 1. Meaning, if you have an event in which the entire sample space is there, the probability of entire sample space is 1. That means probability of sample space is equals to 1. So this is my second axiom. Axiom number 2. Okay. First axiom was every event will have a probability which is either greater than or equal to 0. The second axiom is the probability of sample space. So probability of, any outcome that is there in the sample space that is positive. Something will happen, definitely. Probability of sample space is 1. What is my third axiom? Axiom 3. It can be a little tough to understand, but I'll explain it properly using diagram. Okay. So what is axiom 3 saying? That if A1, A2, up to AN, and these are going on, if this is an infinite collection of disjoint events. What does that mean? That I have an event A1, A2, A3, A4, up to AN plus 1, 2, blah, blah, blah. It keeps going on. This is an infinite collection of disjoint events. What is a disjoint event?
Ma'am, whose intersection is 5.
मतलब जो भी मेरे A1 में हो रहा है वो A2 में नहीं होगा, जो मेरे A2 में हो रहा है वो A3 में नहीं होगा, या किसी के साथ कुछ भी कॉमन नहीं है, राइट? So if I have an infinite collection of disjoint events, so all these events are disjoints, they have nothing in common, and this is an infinite collection. There is no end to this collection, A1, A2, A3 up to AN, and it can keep going on till further end. Okay? If you have an infinite collection of disjoint events, and if you have to find this probability, if you have to find what probability? Probability of event A1 union A2 union A3 up to union AN, up to it keeps going on because it is an infinite collection. That probability can be calculated by doing what? Simply adding the probabilities of these individual events. So because you can just add all these events, I going from 1 to infinity. What does this mean? What does this term mean? That probability of union of all of this is nothing but, probability of A1 plus probability of A2 plus probability. Is tarike se it can keep going on, and it can keep going on, right? Why did I write infinity? Because this I is not ending. This is an infinite collection. Is that okay?
Ma'am, if we roll a die, then the collection of disjoint events would be finite. So it is applicable to some of the sample space or events.
Not necessarily. जैसे for example, आप एक die roll करते हो. If you roll a die, I can define infinite events. See, my first event is getting 1. If I'm getting 1 or not. Okay. Second event is getting 2. Third event is getting 3. Fourth event is getting 4. Fifth event is getting 5. Sixth event is getting 6. Seventh event is getting 7. Eighth event is getting 8, 9, 10, 11. And this can keep going on. I will have an outcome here. I will have an outcome here. I will have an outcome here. I will have an outcome here also. I will have an outcome here also. I will have an outcome here also. I will have no outcome here, right? No outcome here, no outcome here, no outcome here, no outcome here. And it can keep going on. But it is still an event, right? It's just that this event doesn't have any member, right?
Okay, ma'am, I know.
But like I can define a list of infinite disjoint events, right?
Yes, ma'am.
So it is talking like that. So even if, even if your sample space is finite, you can still define a list of infinite disjoint events, right? So what is this axiom saying? That if you have an infinite collection of disjoint events. And if you have to find the probability of this union, it can simply be found by doing what? Summing the individual probabilities of these disjoint events. That is this axiom. Is that all right?
Yes.
Fine. Clear? Okay. So far, all good?
Yes.
Chalo ji. All right. So अभी हमने क्या define किया है? We've defined 3 axioms. And if there is any result which can be proved or which can be derived from these 3 axioms, that will not be considered as an axiom. That will be a theorem. So what do we try to do? Whenever we create axioms, we always want that this list of assumptions should be as small as possible. I don't want to assume so many things. I want to assume the least possible things. मैं जितना छोटा अपना लिस्ट बनाना चाहूँ, मैं चाहती हूँ कि मेरी जो लिस्ट ऑफ एक्सियम्स है, वी वांट द लिस्ट ऑफ एक्सियम्स टू बी as small as possible. Rest, anything which can be derived from those axioms, I will derive it. But I want this list of axioms to be as small as possible, right? So basically, so the basic point is, I don't want to assume anything which can be proved, right? If something can be proved, I don't want to assume it that it is true. I will prove it, right? We
Yes.
want our axiom list to be as short as possible and not contain any property that can be derived from our other axioms on the list. So if I have some property which can be derived using the axioms that I have, I don't want to assume it, right? I will prove it. Okay? Because, here we have that the probability of the sample space is 1. We might also have this urge to say that, okay, one of the axioms should be that probability of a null event is 0, right? ऐसी अर्ज आ रही है कि नहीं, कि ये भी अज्यूम कर लेते हैं ना कि प्रोबेबिलिटी, अगर कोई नल इवेंट है उसकी प्रोबेबिलिटी 0 बोल दो, राइट?
तो मैम पर उसे प्रूफ कर सकते हैं
उसको हम ये 3 एक्सियम्स का यूज करके, 1 2 3 जितने भी हैं, जितने भी एक्सियम्स लगेंगे, वी कैन यूज दीज एक्सियम्स टू प्रूव दैट इज व्हाई वी विल नॉट कॉल इट एज आवर एक्सियम. ओके, दैट इज द लॉजिक. सो यू वांट टू कीप दिस लिस्ट एज स्मॉल एज पॉसिबल. Assume least things. Anything which can be proved, let's prove it. Don't assume that. Okay. All right. So again, coming back to probability of null event is 0, let's try to prove that proposition. So what do I want to do? I have a proposition. Proposition. What is a proposition? It's any statement which could be true or false, right? So I have a proposition. If I'm able to prove it, it's a true proposition, right? So I have a proposition. What is this proposition? That probability of a null event is 0. Okay. Where this phi is the null event. Is that okay?
Yes.
And we also have one more proposition added to this, that whenever we say that probability of null event is 0, that means, this in turn implies that the axiom 3 that we had, it holds for a finite collection of disjoint events as well. So if this statement is true, that means this third axiom that we had now, where we had infinite collection. So here what they are saying, if probability of null event is 0, this particular condition holds for a finite collection of disjoint event as well. So A1, A2, A3 up to AN, let's say these are the finite disjoint events. So the probability of their union will be nothing but I going from 1 to N. So that is basically the next part of that particular proposition. So if you are able to prove this, we will also be able to prove that. But now the burden is on us to prove this. Is that fine? This is the statement.
Yes.
Okay, so chalo, let's see. Okay, fine. Chalo ji. Let's prove that. So how do we prove this? So how do we prove? Let's see. Let's say, let's consider an infinite collection of disjoint events. Okay. So let first consider first consider the infinite collection. What is the infinite collection of events I have? That my event A1 is a null event. My event A2 is also a null event. My event A3 is also a null event. My event A4 is also a null event. And like that, I can keep going on, right? My event AN is null event. And similarly, I have infinite events which are null events, right? Is that okay? So what I did was I created a list of infinite null events. Is that okay? What is the intersection of two null events? If there is an event which has nothing, if we intersect it with an event which has nothing, what do we get?
5.
5 only. If two events have nothing in there, the intersection will also be nothing, right? So can I say that A1, A2, A3 up to whatever this list is, they are all disjoint events because their intersection is 5? Yes or no?
Yes.
So we can say that the events in this collection are disjoint. Okay. Fine. And if you take a union of A1, if you take a union, meaning if you take a union of A1, union A2, union, like you keep going on, AN, if you keep going on, what do you get? What is the union of phi, union phi, union phi? What is the union of all the null events?
Of 5.
If everything is null, even if you take union of infinite events, it's going to be null only, right? Yes.
Yes.
Right? Okay. So that means union of AI is phi. So that is basically a way of writing that union of AI means union of A1, A2, A3 up to AN till infinity, right? I can say that, right? So
Yes.
far, so good. So this is true. And yeah, this is also true. So now what I'm doing, what did my third axiom say? My third axiom said that, if you have an infinite collection of disjoint events, the probability of their union will be this infinite sum of the individual probabilities, right? Yes or no? So let me use this theorem here because all these events, the way I've defined them, they are all disjoint, right? And this is an infinite collection. So I can use axiom 3 here. So I will use axiom 3 here. And when I'm according to axiom 3, according to axiom 3. According to axiom 3, I can say this. So what is the probability of this union? What is this union that I have here? This union is what? Phi,
Yes.
right? So this on the left hand side, it is phi. And on the right hand side, what do I have? Summation I going from 1 to infinity. What do I have? Probability of AI. Any event that I take, it is phi only, right?
Yes.
So basically probability of A1 is actually probability of phi, because A1 is phi only.
Yes.
Similarly, probability of any AN is also probability of phi only, right? So this is nothing but probability of phi. Okay. When can this number be equal to this number? So, let's say, what is the only possibility when you have, so, what are you saying? That this side is exactly equal to this side, right?
Yes.
If this number is anything, because I know that probability of any event is greater than or equal to 0. Let's say this is something which is not equal to 0. Okay. For example, let's say prove by contradiction. Okay. Let's say the probability of phi is not equal to 0. So that means it has to be something positive, right?
Yes.
Anything which is positive, right? Yes or no?
Yes, ma'am.
So even if you put a number which is this, that okay, 0.00001, if you keep adding it infinite times, what is this addition going to tend to? If you are adding it infinite times, what are you going to get?
Infinity.
Infinity. So this side can never be equal to this side, because this side will become infinity the moment you have any positive number here of probability of phi. Yes or no?
Yes, ma'am.
So what is the only possibility under which this side will be equal to this side?
0.
Only when probability of phi is 0, right? So that is how we have proved it. Because, so what are we saying? This can only be true. This can only be true if probability of phi is equals to 0. Because the moment it is not 0 and anything else, you will see a very small number or anything that you put here that will be equal to infinite. So a number cannot be equal to infinite. That will be a contradiction, right? So hence we have proved it. Hence proved. Right? Is that okay?
Ma'am, I'm not able to understand that there is written that axiom 3 is valid for a finite collections of disjoint events.
Okay. This one?
Yes.
ये statement आपको नहीं समझ में आ रही है?
मैम ये वाला समझ आ गया, बट जो हमने यूज किया प्रपोजिशन में कि उसे हम इम्प्लाई करके चल रहे थे कि वो फाइनाइट कलेक्शन ऑफ डिसजॉइंट इवेंट्स में वैलिड एग्जाम 3.
हाँ, इसको अभी हम लोग प्रूव करेंगे. विल प्रूव इट नाउ. सो इस स्टेटमेंट का मतलब क्या है कि जैसे यहाँ पे आप क्या बोल रहे थे, here you were saying that if you have a infinite collection of disjoint events and if you take their union, it's the sum of all these events going from 1 to infinity. So जो हमने जो स्टेटमेंट लिखी है there, that means if it is valid for finite collection, that means let's say if I don't have infinite collection, let's say I have n events and they are disjoint, then the probability of their union will be sum of those probabilities, sum of the probabilities of those events. So let me write it. So basically, what is this theorem going to say? That because once we have proved that probability of phi is 0, what is the statement that we are saying? That if A1, A2 up to AN is a finite collection of disjoint events, then probability of A1 union A2 up to union AN is nothing but summation I going from 1 to N probability of AI. This is the statement. Now, so what we are saying is axiom 3 is applicable for infinite collection. So we are saying it's also applicable for a finite collection when your number of events are limited. When the number of events are limited, then also you can find this probability of union by simply adding those probabilities. This is a result, right?
Yes.
So that is what we are saying here. When we said that this particular thing would imply that this third axiom will hold for a finite collection of disjoint event as well. So there we had infinite collection. So this holds for this finite collection. When you have limited number of events, and if you have to find the probability of their union, that is simply the sum of those probabilities. That's all. This is the statement now. Okay. Is that fine?
Yes, ma'am.
Okay. So now we have to prove this. The moment we have proved this, now we will use this and axiom 3 to prove that actually this holds true. Okay. This is another proposition that we have. All right. So now what you do is, so let's say, so this statement is clear now, Anshika?
Yes, ma'am.
ठीक है. तो अब हमें क्या करना है कि भाई ये जो चीज थी axiom 3 एक्चुअली फाइनाइट कलेक्शन के लिए भी वैलिड है. ठीक है. तो क्या करेंगे? Now suppose that you have events A1, A2 up to AN. They are disjoint events. So these are disjoint events, right? And what you can do is you can add a list of other events which are null events. So basically what we are doing, and append meaning add, append to these events the infinite collection AN plus 1. Let's say I define one more event which is like this, AN plus 2, which is 5. Similarly, I can keep going on. So these were your finite events that you had. These were your limited number of events that you had. And now you are saying, okay, let me add some more events which have no element in them. This is fine. So you had this list of events. What you are trying to do here is, basically you have to prove this statement that if this is a finite collection of disjoint events, then this probability of union is actually this. Is that okay?
Oh, ma'am, what is the meaning of append?
Append meaning add कर रहे हो आप. तो मेरे पास ये n events थे, आप इसमें ना ये सारे events और add कर रहे हो. Going from, अब n events तो थे, आपने बाकी और events add करना शुरू कर दिया. n+1, n+2, n+3 ऐसे till infinity. और ये जो सारे events थे, इनकी property क्या थी? They were null events. Okay.
Yes.
So now you have an infinite list of infinite collection of disjoint events, right? जिसमें null है उसका आप intersection करोगे, so that will be disjoint only, right? So basically now you have a list of infinite events A1, A2 up to AN. ये हो गए, and then this event AN plus 1, AN plus 2, like this. And all these are null events, right?
Yes.
So basically, this is your list of infinite disjoint events. Yes or no?
Yes.
And because you have a list of infinite disjoint events, you can apply axiom 3 in this case. Yes or no? Right? If I have a list of infinite disjoint events, I can apply axiom 3.
Yes.
So axiom 3 will tell me what? That probability of A1 union A2 till union an plus 1 till infinity, that is nothing but summation I going from 1 to infinity probability of AI. Yes or no?
Yes.
Right?
Yes, ma'am.
These were your events. These were your initial events. And all these events that you have, they are all null events. They are all null events. So if you take a union, which is this is nothing but a union till here only. If you keep taking union with null events, nothing is going to get added, right?
Yes.
So can I write it like this, that this is actually this only? This is probability of A1 union A2 union AN only, because these are all null events. And if you keep taking a union with null events, nothing is going to get added after this, right?
Yes.
And then how can you write it? Can I write it like this? That I will just first sum I going from 1 to n probability of AI, and then I will add all these events. I can do that.
Yes.
मैंने क्या किया? I did this. That okay. इसको कैसे लिख सकते हैं? Probability of A1 plus A2 plus up to probability of AN plus probability of AN plus 1 plus ऐसे करके. तो basically इसको अलग से sum कर दिया, I going from 1 to n, and इसको अलग से sum कर दिया, I going from n plus 1 से infinity, right?
Yes.
Or no? And you know, because all these events after n plus 1, including n plus 1, they're all null events. And I have just proved that this null event probability is 0, right? We've just
Yes.
proved. So if you keep adding 0, 0, 0, 0 infinite times, what are you going to get?
0.
0 only. So what is this? This will be 0. And what is this? Summation I going from 1 to n probability of AI, right?
Yes.
So have I shown what I wanted to prove? I wanted to prove this only, right? That probability of A1 union A2 union up to AN is actually summation I going from 1 to n probability of AI. यही तो prove करना था मुझे, right?
Yes, ma'am.
So we have proved it. Hence, proved. Is that okay?
Ma'am, is this applicable only in the case of 5 null sets?
So basically, हाँ मतलब मेरे को क्या करना है? I have to show that this particular axiom 3 is applicable for finite also. So I will artificially create something so that I can apply axiom 3. Because I have to use axiom 3, I have to create my system such that it gives me this. So yes, we have artificially created an example so that I can use the axiom 3. So it's only applicable in case of phi. Okay. So phi we are using to arrive at this conclusion so that I will be able to use axiom 3. Otherwise, I have no other option because I can't assume anything else, right?
Yes.
So we have used phi so that, you know, we can use this thing that we have proved that probability of phi is 0. Okay. All right. Guys, I can understand this could be a lot for the first time you are doing these kind of proofs, right? And never in your life you've ever done this. You've always assumed things, taken them for granted, and just problem solving pe you used to have focus. But thoda thoda from now on, because कॉलेज में है हम लोग और थोड़ा सा इन डेप्थ वी आर गोइंग, सो वी विल कीप प्रूविंग थिंग्स टाइम एंड अगेन, ठीक है. So what I will suggest is that please do this proof on your own. Go back if you have any doubts in any step, let me know and we will continue again in our next class. So इसके बाद जो भी हमारी चीजें हैं, so axioms से और क्या क्या results proof हो सकते हैं. So sometimes these proofs also come in your exam, so we can't skip those proofs. Okay, so it's not like just ठीक है भूल जाओ समझ गए कोई बात नहीं, but you have to do these proofs. Okay, all right, let's pause here for today and yeah, okay guys, any doubts so far?
No.
ठीक है, एक बारी इसको फिर से हाथ से कॉपी पेन पे अच्छे से प्रूव करके देखना, कोई स्टेप में दिक्कत है तो लेट मी नो, ठीक है. ऑल राइट, ओके गाइज, थैंक यू सो मच, टेक केयर एंड हैव अ गुड रेस्ट ऑफ योर डे.